Hello everybody, I am Stéphane Coche, Director of Sales of APREX and partner as well.
So hello, thank you to be here to share our experience of computer vision. It's not a technical presentation, but it's a feedback of a project to how you deploy this project in our company to detect defect hologram and how you manage this project with APREX solution. So I'm Flipo, I'm Director of Industrial Program 4.0 and Investment at INGroupe. So short presentation of our group. INGroupe is now 4,000 employees all over the world. We are specialists of identity and trust service. We provide 20 million passports every year for different countries. France passport is almost 5 million passports. We have also 4,000 employees all over the world. You have 8 sites in France, 22 centers of expertise or research in Europe, 75 partner government, and 130 users country who use our solution. So we are also the #1 of digital secure identity in the world. So I told you some many scale players. It's 20 million passports every year to produce in 3 plants in Europe. 50 million digital identity managed. 70 million ID cards per year. 1 billion identity managed and 2.5 billion hologram. And it's a project we work together with APREX to detect the defect of hologram.
Thank you, Eric. APREX is a French company, so we are based in the east of France. We have 5 branch offices and we are specialized in computer vision for industrial projects and R&D projects based on computer vision. So we have more than 15 years in R&D, and we have driven since 2017 more than 1,300 projects in computer vision, and we do that across different industries, so plastics, siderurgy, printing, cosmetics, nuclear, and so on and so forth. So as you can see, here we are industry focused. We have put a couple of our clients. So it's not all of our clients, but it demonstrates that we can cover different industries, first of all. We have our own platform to develop applications. So we can manage unsupervised AI, supervised AI, parametrics techniques, if you want to deploy some projects. And we do, this is a unique, we do end-to-end projects. So we have a doctor in physics, so we are able to identify what kind of devices we will be using for your projects. We are using our own platform to develop the application, and after we install that on your production line.
So this is an overview of Industry 4.0 and workstream we deploy in different points of INGroupe. First, we are part of Alliance Industrie du Futur, and we receive Vitrine Industrie du Futur this year for this project, computer vision, and also for the environment project. This is a different pillar of our Industry 4.0 workstream: automatization, computer vision, real-time tablet, IoT architecture, RFID and identification for supply chain, digital twin, mobile robot, and also solution for digitalization with application with no code. So the different projects for this project will be this project step by step to define donc the OKR, objective key result, why we would like to start this project, what is the defect, the no quality internal and external no quality. And this is the first step. Second step, we realize a user journey with the operator in the workshop to define what's the difficulty to manage the quality, what different solutions we use to manage the quality, and what is the irritant of manage the quality. The third step was to study the solution and why EA and computer vision can resolve our problem to detect with variability, with different projects, how EA can resolve our problem. So we make a test with 6,000 images, and after 1 week, we had a good result with 75 of no quality was detected. After we defined the challenge of the project to detect accuracy 200 micron, it's almost 6 images per second, and the process time it's under than 145 milliseconds. And after we'll give you the benefits and the next step for the deployment of the solution.
So the computer project, as Eric has described, is to detect the defects on hologram. So there are a couple of key challenges. Well, first of all, you see an hologram, so you can see the hologram, it appears, it disappears, it appears. So first of all, the project itself is quite complex. It took after practically between 6 to 7 weeks just to identify what kind of device we will put in place and how we will put in place in order to capture the information from the hologram itself, right? The size of the hologram, as you can see, is quite small and is variable. You don't always have an hologram of 25 millimeters. It can be bigger, it can be smaller. The size of the defect, originally speaking, when we have started the project, it was 200 microns, and currently we are identifying the defects lower than 90 micron. Just to give you an idea, 90 micron is just a hair. A hair is 80 micron, 80. So that's the size of the defect that you are looking for on this product. We have the speed of the machine. Okay, it's 40 meters per minute, so it's quite speed in order to identify the defects. And the space. The machine is really compact, so you can't do whatever you want. You have to set up the camera, the devices, and you don't have a lot of space. Okay, it's like a car and a motor. You don't have a space to put everything into the car. So those are the challenges that we have to manage to do the project. So how did we do that? So first stage, as I explained, 6 to 7 weeks in order to identify what kind of devices we will put in place into the machine. It's the first step. We have worked closely with the operator and with Eric's team in order to identify what kind of information do you want to receive back in order to interpret and to make decisions. That's important. Compatibility with the IT infrastructure, because it's an identity product, so you can't do what you want. Okay, they provide the IT, so we have to make sure that our solution is compatible with their solution. Then the mechanical integration. So how do we put things into the machine? Once we have set up this, okay, we can start the AI project. Setup is in place. We capture the information. We do the AI, we're using the model, the algorithm. We build the application, we deploy, and after we put into an industrial mode.
So this is the implementation timeline. So we start the project in 2023, and we start the production in last year, and we finish actually the industrialization in January, and we'll project to upgrade accuracy for detection 100 micron, and also to deploy in other plants and in other process this solution. Et les bénéfices?
So we are very close. So if you just cross the corridor, we are on the I-12. So if you want to have more information about computer vision and what we are able to deliver in the industry, well, feel free to come and see us on the I-12. Thank you very much for your attention.